All right, here's what we're going to do. We are going to finish this problem of finding the equation of the sine graph that would best model this data that we found earlier today in class. All right, so we already did the amplitude, and we already determined the vertical shift, or the midline. This is the midline. Okay, and we already did the horizontal stretch factor. This was the period, and we found that to be pi over 6. Okay. Now we go on to the tough part, which is the horizontal shift. So before we get there, let's recap. So far, our equation should read as y equals 26.5 sine of pi over 6 times the quantity of x, and then here's the number we got to figure out what to put in there, and then plus 56.5. Okay, so here's how we do horizontal shift. First, we need to examine a regular sine graph. In this case, our last number is going to be 12 because there's 12 months. That's the period. And then we break it up, that'd be 6, this would be 3, this would be 9. A normal sine graph would start here at the axis, and then go up, and then go back down to the axis, and then go down, and then back up to the midline. Then would graph the function. All right, this sine graph has a relative maximum at 3. So the goal of this horizontal shift is to take this relative maximum and shift it over to where we want it to be. So in order to figure out where we want it to be, we look at our data and we find out where there is a maximum. So where is the relative maximum of our data? And we kind of already found it in the other steps, but it looks like we have it here with July and August. Now July is month 7 and August is month 8. So the x value that we're concerned about is right between July and August, 7.5. So we want to take and we want to shift this graph from 3, we want to shift it all the way over to 7.5. So that would, this would be 7, this would be 8. We want to shift it, right here to 7.5. We want to shift it all the way to right here. Well, in order to do that with our equation, we have to input a number in this spot right here. Well, that would be, because we're shifting it right, we need a negative, a minus sign here. And then however much we're moving it. In this case, from 3 to 7.5, well, 7.5 minus 3, that would be a value of 4.5. So minus 4.5. And that's how you get that number. So again, in recap, we want to move this relative maximum that's right here. We want to shift it over to where it actually should be and for our data. And the relative maximum for our data is between July and August, so at 7.5, because July is month 7 and August is month 8. So between those is 7.5. All right. Final thing we need to do in order to clean up our equation is to distribute that back into there. So we'll end up with y equals 26.5 sine of, and then multiply pi over 6 times x, you get pi over 6x, and then pi over 6 times negative 4.5 is negative 4.5 pi over 6, and then plus 56.5. All right, and it looks like I still have some time left on the video, so here's what I'm going to do. I'm going to make a graph on Desmos.com of all these points. Let's see how much time we have left here. I'm going to pause the video here real quick and input all the points from our data into this Desmos calculator, and then I'm going to come back and talk to you in a minute, just so that way the movie doesn't take forever. So hold on a minute. All right, so I took all the data from this table that we had for the average highs and the months, and I put it into Desmos.com. January being 1 to 0.130, February 240, so on and so forth. So it looks like this: 130, 240, 359. All those points, I got to zoom out on the graph, they're up here. And as you can see, we have part of a sine graph. So now I'm going to take the equation that we found earlier and type it in. And hopefully it will fit the points very nicely. Y equals 26.5 sine of pi over 6 divided by 6 x, and then minus 4.5 pi over 6. And it looks like it's fitting pretty nicely. The only thing we need to do is bring that whole graph up, which is what the midline will do, plus 56.5. And there you have it. It looks like it fit the data, not perfectly. Of course, we wouldn't expect it to fit perfectly, but relatively close to our data points. So that is that's how you do it. And good luck with the homework.